Okay. I just want to check, so one final time here. Can you all hear me? Good. I will record this session as well, and I will publish that on our web pages later. So you can read, and also the slides will also be available. I will also have a short chat session after the presentation if you have any questions. It's all a bit first time for me as well, so I hope you have some patience for this. Okay, so we're going to talk about storage today and data transfers. So you all are users of LUNARC, hopefully, and you probably have this problem all the time. How do you get my data to and from our systems? So I will try to cover the different ways you can do that, but also what kind of structure we have in our system. So this picture shows you how a very high-level architecture of our Aurora computing system. So Aurora consists of several compute nodes, and every compute node has a hard drive installed, which you can use for temporary storage, or if you have programs that are heavily swapping or doing I/O that is only for the job, during the lifetime of the job, you can use this temporary storage. Every node is also connected to the LUNARC center storage system, which is available under /LUNARC, which is the main storage infrastructure for the computing cluster. So these are I will come back to these are the home file system and the project storage areas. They're also located on the center storage file system. You also have access to, if you apply for it on SNCC, the SNCC National Storage System, which is a FTP-like system for transferring larger archives of files to from the system, so you can make space available on the center storage system. When you are logged into LUNARC, you have also you have full access to the internet from the front-end machines and also from the nodes. So it's possible to download stuff from the internet directly to the center storage system using any web protocols. I will show you some of them in this talk as well. But basically you have FTP, HTTP, and SFTP, which you can access from inside the system. You can also access the file systems from using the SFTP storage protocol, which I will illustrate later on. So as I said, each node has a local disk. This data is not shared between nodes, so if you write something on one node, it will not be available on the other node. Also, the data is destroyed after the job, so it's only for temporary storage. You can access the location from a job using the SNCC TMP environment variable. But you should use this only for scratch I/O operation. So if you have a program that needs some kind of scratch space, you can specify this variable. So the storage available on a system is the parallel file system or the center storage system, and it's available LUNARC No Backup projects and XXX, and you also have a home directory, which is your private directory, which is also located on this center storage file system. The center storage file system is an IBM Spectrum scale, which is a highly parallel file system, scales extremely well, and you can write multiple streams from your parallel jobs directly to this file system. This file system is shared between nodes, so if you write from one node, it's available on other nodes as well. It also supports parallel transfers in MPI jobs. Also, a new thing that we have recently implemented is project storage. So except for your home directory, all other storage must be applied for through the super system. So if you want a project directory that is larger than your home directory quota, you need to apply, or your PI needs to apply for a project allocation, a storage allocation. And this project can be shared amongst several members of the project as well. There are some environment variables controlling or making it more easy to transparently move between systems within SNCC. So we have set all these variables on Aurora as well. So you have something called SNCC backup, which is the home directory. So this is a backed up directory of our system. The project storage is non-backed up, and it's this is wrong here. I will fix that in my final slide. So LUNARC no backup projects, that is on the location. SNCC resource is an environment variable which provides you with the name of the current system. In this case, it's Aurora. SNCC site is the center, and SNCC TLP is the temporary directory, as I showed before, on the local node. National storage infrastructure is available to all centers in Sweden, all users. It's not mounted as a file system on our machine, so it's very similar to what you do in FTP size. You log in and get files from that system and download them to our resource. You need client tools to access them, and we have two major systems in SNCC. We have Gcache, which you use something called R client or IRODS client to access IROD systems. Those are installed on our systems as well. And the national storage is intended if you want to move off data results temporarily from different systems or move between the systems, you can upload to this storage infrastructure. However, it's not a highly parallel file system, and it's not designed to handle thousands of small files. It's better that you archive your data and upload to this system. So large volumes, high latency. It's also redundant. It's not backed up, but it's redundantly stored. So when you store something on national storage, it's always located on two centers in Sweden. So two geographically separated locations. But if you delete it on one place, it will be deleted at both places at the same time. So transferring files. So the main way of transferring files to and from our system is through SSH, and there are multiple storage clients you can use. You have the Linux. If you are on Linux, you can use the SFTP tool, which is built in most of the Linux distributions. Mac OS X also has a command line tool called SFTP, which also is built in. There is a graphical client, which I will show in later slides, which is called CyberDAC, which provides you with a drag and drop interface to moving files to and from Aurora. We also have on Windows, the best tool is probably to use the command line or the graphical user interface client WinSFTP. And WinSFTP is looks like a file explorer window, so it's very easy to use. You can just drag and drop files between your files on your local machine to Aurora. There is also a command line tool, part of the PuTTY installation, which is a terminal installation, which also contains a command line SFTP tool, which you can use from the Windows command line. Another option that has been quite common recently is using something called the Windows subsystem for Linux, which is basically a native Linux environment within Windows. And it provides you with an Ubuntu distribution with all the command line tools from Ubuntu. So here you have access to the WinSFTP, the SFTP tools directly from the command line. So from the basic, the main tool to use if you're using command line is the SFTP tool. And that tool is also what is used by the WinSFP and the CyberDAC graphical clients. So underneath that, it uses the SFTP protocol, which stands for Secure File Transfer Protocol. It's part of SSH tools that are installed on your clients. And also from within the LUNARC resources, you also have the ability to use SFTP to access other systems within SNCC. So you can use SFTP to access systems in Linköping or Umeå and download files to your resource. If you have files that are available on web resources, you can use the command line tools vget or curl to transfer files to and from our resources. And also, as I said before, the National Storage Infrastructure uses specific clients to actually upload and download files. So there is ArcCP, for example, for copying files to the National Storage Infrastructure or downloading from the National Storage Infrastructure. IRSync can be used is for IRO systems. So I will try to do this live as well. So I will try to show you how to log in. So instead of just showing boring slides, I will try to use, let's see if I can. So do you see the screen here now? There should be a terminal available.
Yes.
Yeah, good. So now I'm actually using the Windows subsystem for Linux to actually demonstrate here. So this is a Ubuntu command line tool in Windows here. So it has all the commands. So what I'm going to do now is I'm going to SFTP to the system. And the command line tool is SFTP. And then you will type your username at aurora.lunarc.lu.se. I hope all the internet gods are with me today. So you log in using the same techniques, using one-time passwords here as well. So now I'm inside on Aurora. So now I have a SFTP prompt here, which means I'm logged in and I'm actually on Aurora now. So if I do ls here, I see my files on the Aurora system. So this is not a normal command line prompt. It's a file transfer tool. So now I see I have not cleaned up my directories here, so you have to excuse myself here. You can also list the local files on your own system, and then you prefix the ls command with L, so ls. Now I see I have the files which I had in my directory when I logged in. Those are available here. I can change my remote directory here using the normal cd commands, or I can go into development here, which is my development directory. I do ls, I have my files here. You can also change the local directory. So let's see here what I have in my, no, I don't have, yeah. So I can do lcd, which is local change directory. So now I have, this is my LLS. This is my local directory here. I can go in my storage again. Storage example. Sorry, LCD storage. So every time I want to work with the local, I have to prefix it with an L. So now I'm in that directory. So if I want to upload a local file, I can use there's a command called put, So put will put a file from your local file system to Aurora. So for example, here, if I want to put the 5.11.zip file, do put. So now I'm sitting on a slow link at home, so it's not that quick. So if I now look at my directory here, I see that there is a 5.11 file here that has been uploaded. So if I want to download a file from Aurora, I use the get command. So get, yes. So in this case, I just get, for example, the Python file I have here. And I just and if I do LLS now, I should have that in my directory. So yes, Python 3, I downloaded that from Aurora. So of course, you probably want to download multiple files, and you can do that using or upload input and mget. So let's say just create a directory. I can do input star, and it will upload all the files from my local directory. Perhaps that should was a big file here, but so, and the same file you can do mget. Now I just get a simple one here, star cpp, and it downloads that. So mget and input for wildcard or multiple files. There is a lot of commands in the SFTP. So if you want to see what kind of commands you have available, you can do help. So there is a lot of options here. I don't go into full depth on all of them, but you can do quite a lot with using SFTP. So let's see here and go back to my in many cases, you also have files from web-based resources you need to access on your computer or on Aurora. And what you can do to easily download them. So if you are using our desktop system, you can open a web browser. You can open a web browser from your local machine as well. Select a file and just do copy link location. Then you will have a URL in your clipboard, which you can use from the command line tool. So in this case here, I do vget from the link, and then I just paste in the link here and download the file. So you see here it downloads the file. So vget is also a very good command if you have files you need to access from URLs on the web. just copy them from the browser and just vget to get them to download on your machine. So because Aurora has full internet access, this is completely possible. They also have some graphical clients available for you to use to download files. For example, you have CyberDAC, which is a Mac-based client, which can download files from multiple different protocols, but it can also download from SFTP. So to access Aurora from CyberDAC, you need to create a new bookmark. You also need to specify which protocol, which is done in the top window. Also the host name you want to access, in this case is aurora.lunarc.lu.se. You specify host name and the username. What you also need to do is this part below here. So this here is very important. Because if you don't do this, it will CyberDAC will retry to access the system all the time, and you need to prompt for a one-time password every time you want to transfer a file. So you need to make sure that you use browser connection. Then it will reuse your existing connection to download all the files. Okay. Sorry. Yeah. When you have defined your bookmark, you just open connection or double click on the bookmark in the main window. Then you will be asked for a password and your one-time password as well. Now you have a window which you can drag and drop files from your local system to Aurora and the centralized system there. You can also ask Aurora to be your default application for SFTP location. So if you're using your Finder and you access, you type in the full SFTP location, it will open CyberDAC. WinSFTP, I can show you live, so I'm going to do that. So the first thing you have to do, same thing with CyberDAC, you have to specify aurora.lunarc.lu.se. You also make sure that you have the SFTP protocol here active, the username, then I have to copy my password. And then I type, you can save it here as well, and then you have your session saved here in the left side. So now I need to specify my. So now I'm back on Aurora. You see here I have my development folder. I created my storage folder here, and here you see all the files we uploaded previously. And you can open and it's uploaded to Aurora. You can do the other way around as well. You can download a file like this, and it goes the other way around. So it's quite a useful tool. So SNCC National Storage, at the end I want to just talk about a little on how do you get access to these. I told you a bit about it before. So in the SNCC National Storage, I think we have more than 25 petabytes now. I think it's over 100 petabytes of storage. It's available through the Dcache IRODS protocols, which is used in many research infrastructures for storing data. It's a distributed storage system, so you have a central metadata repository at some location, and then it's you use and the storage is distributed on several storage servers spread around the country. And you can use the protocol SRM or GSI-FTP, which is also commonly known as grid FTP. You can apply for national storage by going to SNCC, allocation Swiss, or then you can see what options you have. So you can get small allocation up to 10 terabytes, medium 50 terabytes, and large over 50 terabytes. Large are there's a review process, a scientific review process, and there are 2 application rounds for those. So those take more time. But medium allocations up to 50 terabytes you can get quite quickly. Also, currently the policy for SWISTOR is not it's not a backup system or archiving system. It's more for convenience system for transferring data between sites or making more available on your local storage system or the central storage system. So also you have to think about the data management here. So currently in SNCC, data is stored on machines and national storage is for active use. So you need to have a plan to transfer your data somewhere at some point. And I think when you're PI or you have applied for storage, you have to specify that you have a data management plan. So it's the universities that are responsible for making sure that you can move your data back to Lund University, for example, or somewhere else. So, but this could all change in the future. We don't know. It could be that SNCC is giving a mandate for actually storing things for a longer time, but it's not there yet. So this is the page for applying for national storage. So you can apply for small and medium, and then you can create a proposal where you describe what you want to do with your data. You describe what's in your proposal here. It's very similar to applying for compute time. And then you can select what kind of resource you want. So you can select the Dcache or iRODS. And to access the data set, when you have applied for a project, you will be probably contacted to generate a username and password for accessing it. And this slide shows you how you access it from the Dcache system. Unfortunately, the Dcache system only supports read-write from a command line tool. So you need to use the ARC client tools to actually do the authentication. I think this is changing shortly as well, so you can use the username and password. Also in the future, it could be that the file systems and national storage will be available directly as a file system mounted on LUNARC. You can also use the system for web app access from Windows, Mac, and Linux. Please see the web pages on SNCC to how to access the machines, because there is more documentation which is changed all the time. You can also access using grid FTP, also using WebDAV. So WebDAV means that you don't have a special client. You can actually access from your machines as well, directly from, for example, File Explorer or something like that. Commands to be used to copy is arccp, arcls, arcrm for removing files. They correspond basically to the commands you use for copying files on Linux. So this is a typical here. I have you type arccp and then you type your file name and then where you want it to go. So in this case, GSFTP, SWISTOR, OPS, Jonas. And then there's also an option to provide interactive progress bar to see how far it has transferred files. As this is a complicated protocol, you can also add debug here to see the progress more in detail, what is happening, authentication and stuff like that. It's also possible to do recursion, but this can be a costly operation because this is not a low latency file system, it's high latency. So it takes some time to create directories, move files and so on. So I would consider archiving your data in multiple tar files before transferring over, or organizing your data in less less files. You can list files here as well, so it's very similar to the SFTP tool. Here is a directory listing. Yeah, you can query metadata. So all the data that is stored on SwiStore are checksummed. So also, because it's located on 2 machines, you can see if there are some data integrity problems, and that is automatically handled when you upload your files. There's also a storage explorer that is available on the desktop, which you can use to access the national storage infrastructure. If you have any questions on using that, please feel free. When you have an account on the certificates for Dcache, let me know and I can help you out with that as well. So there is links here to the doc site here where you can get more information on the national storage infrastructure and also all the tools you need to access the data.